This is A-level chemistry. Let us determine the shape of this very particular molecule. Now, the theory that will help us to determine this is known as valence shell electron pair repulsion theory. And in valence shell electron repulsion theory, two things are involved. We have the bonding pairs and the lone pairs. The lone pairs are the non-bonding pairs. So what happens is both the lone pair and the non-bonding pairs will try to move away from the central element, thereby giving that molecule a particular shape. So let us see how we can determine the shape of this molecule. First of all, sulfur is the central element. And you will agree with me that sulfur has 6 valence electrons. So we're going to use electron dot structure to distribute the 6 valence electrons around this sulfur, or Lewis dot structure. Okay, we have 1, 2, 3, 4, 5, and 6. But you will agree with me that one electron has been lost, which is plus, this one plus. So let us remove that one electron that has been lost, okay, because sulfur is the central element, which means there is another element here that lost this electron. Okay, so if such is the case, here fluorine is introducing 3 electrons, and these 3 electrons will come to pair at this electron density area. What do I mean? This place is rich with electrons. Okay, so these 3 electrons will come to bonding or pairing with these single electrons in order to create a covalent bond around this sulfur. So what will happen is this one will come here to bond, and F, this one will come F, this one will come F, and we can do something like this if you like. Don't mind me. You can do something like this. So they have covalently bonded around this sulfur. So if such is the case, we can see the structure somehow. You will say that the structure, remember, this is a lone pair, that is a non-bonding area. There is no bonding that is taking place here. We call it lone pair. Okay, so you will agree with me that we have 3 bonding pairs and 1 lone pair. 1 lone pair simply means a non-bonding pair. So if such is the case, we cannot give this compound or this molecule the shape. So the shape becomes, we have X here, we have F, and we have this F, and the angle here is always 107 degrees. And remember, we have a positive sign here. And the shape of this molecule is trigonal pyramidal. Thank you for watching, and bye-bye.